You are now being connected to your conference.
Hello.
Hi. Or how's it going?
Hey, hi. You can hear me, right?
Yes, I can hear you fine.
Great, cool. How are you doing?
I'm doing fine. I had I'm not too sure about how to approach a particular question, and thought I'd share that with you.
Yeah, go ahead. Feel free to do whatever's best, like send me a file or write it on the board,
Okay.
whatever works.
Is that apparent on your end? Are you able to see that?
Yeah.
Okay, so I mean, we don't have to answer all of them, maybe just a few to get the general idea, but the question is essentially telling me to estimate the value of the derivative at these particular points. I'm not too sure where to start.
Okay, cool. So yeah, that seems pretty straightforward. We should be able to get through these. They shouldn't, because once you get a couple of them, it's the same method for all of them, so it should go pretty straightforward. But are you familiar with how you start these?
Yeah, I mean, for me, it's just like a matter of detail that I think I'm missing somewhere. But I think the general idea is to like draw tangent lines at these points and then try to estimate the rise over run, maybe.
Right. So yeah, that's basically what it is. So if we take, I'll just write out some stuff. So if you take, well, actually, close it like that, something like that, right?
Yeah.
That's off, but so that is, so there's this line, which is a normal line that you can express like this, but it is also like with what you were saying, this tangent line, I guess in this case, has a slope equal to the derivative.
Right.
So yeah, so you don't really need to worry about the intercept at all. So it's just like what you were saying, just like estimating the rise over run. Which if you have like a ruler, then that might be handy.
Yeah, and like as far as the rise over run thing goes, like I'm just trying to figure out like how to do that exactly without numbers.
Yeah, so whoops. Okay, so basically it turns out actually I can get a line tool. So yeah, okay. So that looks like our tangent.
Right.
Now, the basic idea is that you can see there's that point, and then you can pick out another point. So when you have this equation, basically you can say like the rise is change in y, and then the run or the horizontal is change in x.
Mm-hmm. Right.
And so you can kind of like take a little sample of what, so I'll draw like a little replica of what that section of the graph looks like between those points. You have a point that's somewhere about here, maybe a little lower, and then a point that's up. And so this is what the thing looks like, and then our line goes, but the line goes between them. And so like from this, you just kind of have to estimate this distance, and then the horizontal distance. And I like to pick, because here you know that this is 3.
Right.
Of 3. So yeah, I like to pick the intercepts with the grid lines so that you can get like one of the measurements very clean.
Right. Absolutely. Yeah. That makes a lot of sense. The only issue that I'm having is like if for instance, if I chose, I think in this case you chose this big of a triangle. So if I chose, let's say, you know, this big of a triangle instead, would that throw my answer off?
Not really. I just choose them a little bigger just because I like having a bigger diagram to work with, but like the line that you just drew or the area you just had would look more like this. If you look at like where this intercepts the grid line,
Mhm.
and then it would look more like this, but it'll still have the same slope. It might just be a little harder to estimate because it's smaller. Well, maybe that makes it easier. But yeah, then you just change the measurement. So this is 2, and then this, whatever this rise is the same ratio. So you're gonna end up getting the same slope. It's just 2 different ways of getting there.
So the rise, you're saying that the rise is like 1, 2, 3, like 3, sorry, 0, 1, 2. It's closer to like 3, I guess.
Yeah, so like, well, I guess in this case, this would be like 3.2 or something, and this would be like 2.2, something like that. Maybe a little more.
Right. Well, what I wanted to know was like, are you counting starting from the like, are you counting starting from this point, or are you counting like starting from this point? The rise,
Yeah.
that is.
Good question. So you're starting from the bottom point. So if you go back to the equation up here, the reason I have it written as like y1 and x1 is because the baseline can change. So if you wanted to get the slope out of the smaller diagram, the 2-wide one, where I've written y1 and y2, you have to take the value of y1. So you have to take, because it's not going to be 0.
Right.
Because if your line passes through 0, then yeah, that's where it starts. But if your line starts up at like a little above 2, then that's where you start calculating the rise. Because you want to calculate how far it rises per distance x.
Okay. So I guess in this case, we would have 0, 1, 2, and then we would have like 3.1, I think. So the rise would be 3.1, and then the run, you're saying, would be 2, correct?
Yeah. So here is the thing. So you have how do I put this? You have like the rise and run are always like relative to the box I think I'm looking at. So our run is 2, and you can just say it outright only because the markers go like 0, 1, 2 on the grid line.
Mm-hmm.
So the run is actually 2 minus 0, because remember it's x2 minus x1. But because we started at 0, that's just 2. The difference with rise is we don't start at 0, because the graph section we're looking at starts up a little above 2. So like for the little triangle that we're looking at, that's 2 wide, where is the first y point? Where does that land on the y axis?
2.
Right. So then y1 is going to be about 2.
Okay.
And then where is the second point?
The second point.
What is that y point?
So we'll say that's at like 2 and then 3.1.
Okay. So right. So then you have these estimates for y1 and y2. So the thing is, you want to plug them in, because rise is equal to y2 minus y1.
Mm-hmm.
So then you have y2 minus y1, which you plug in 3.1 and 2, and then the difference there is 1.1.
Right. Right, I see.
So then, yeah, so then 1.1 is the rise value that you want to plug into the slope equation.
Okay, sure. And for the rise, or actually for the run, I think we already did the rise, correct? And then for the run, it's just x2 minus x1. So I guess the first x value, or x1 in this case, would be at 0, and then x2 would be at 2, so -2.
I think you have it reversed, because the thing I always, the way I write it is that x1 is the lower number. So I look at, like, because if we write these as points, what I say is that the one on the left hand side is x1, y1. And then the one on the right hand side is, well, I guess in our case, pointing to the one down here.
So you're saying that x1 is always the smaller value, correct?
Yes.
So between 0 and 0 and 2, we'll say that 2 is x2, and then x1 is 0. So it's just 2.
Right. So yeah. So then the run is 2.
Okay. So 1.1 over 2.
Right. And then yeah. So then that is this. Or I'll just write this over here.
And I guess I should have known that it was not going to be negative, because the slope at that point, or not at that point, but the line itself, I think, is positive sloped. So
Right. So yeah, that's another great way to check it, is just by looking, and you'll look at it and you'll be like, you can always compare also to y equals x, like the line of slope 1. So you can see, like, well, it's a positive slope that's a little bit less than 1.
right.
And then yeah, you check the number. Okay, positive 1.1 over 2 sounds about right.
Okay, excellent. Well, I think that equips me with enough understanding to do these problems here. Yeah, I think I feel pretty confident.
Yeah. Do you have any last questions you want to address, or?
I think let me just go ahead and try f prime of 7 here. So
Yeah.
1, 2,
Yeah, I was
3,
gonna say,
4,
you can feel free to do a sample problem to check that you
sure.
understand what.
So if we're looking at 7, so 1, 2, 3, 4, 5, 6, 7. So I guess we're looking at a line that, so 1, 0, 1, 2, 3, 4, 5.
Is it here?
Just trying to make sure. 0, 1, 2, 3, 4, 5, 6. Yeah, right. So we're really looking at a line that is like this here. And
Yeah.
seems like, so I guess we could look at this maybe. That. And the first observation is that the slope is positive, and it seems to run. So I guess we'll do, let's see here. So, I guess what we'll say for the rise is that, it's a little over 1. So the first y value would be a little over 1, is what I'm saying. And like 1.2 or 3. I guess we could have like 2 points here and here. And we'll say that the first point, yeah, y2 would be like 1 point. And then I guess we could go to run. I guess we could go to the run from here. Oh, right, y1. Y1 is 0 because it's directly on the x-axis.
Yeah, and that's like a nice thing about the triangle you picked, which I figured why, because you don't need to look, because you're just like that's around 0, and then you don't need to worry about it.
Right. And then for the run, so x2 we could say is, so we know 7 is at that line, so we'll say that's like 7.7 or even 8. I don't want to say 8 though. And then so then x1, so x2 is 7.8 because it's a larger number, and then x1 is like 6.8. So it would just be 1.2 minus 0 over 7.8 minus 6.8. So it's like 1.2 over 1, it seems.
Yeah, that seems about right. And then if you look, you can see that like the line looks like a little steeper than y equals x and positive. So seems like a decent estimate.
So I guess we'll just round this off to 1.
Yeah, I mean you can. I don't know what precision they want you to go to.
Okay. Yeah.
But yeah, any of that should, especially because it's an estimate. Like anything in the ballpark should be fine.
Okay, awesome. Well, I'm glad we got this down. I'll do the rest of these here on my own, but thank you so much for giving me insight.
Yeah, of course. Yeah, I'm glad to be of help.
Thank you so much. Have a good one, man.
Yeah, you too. Have a good day.